Trico.
This is the example that we are going to solve, and this is the formula. The question is if this exponential is to c, t being less than 0, exponential is negative t being greater than or equal to 0. Our formula is this one. This is a half root of 2 pi integration from negative infinity to unity. And the formula is ft because the function is a function of t because we are reducing to t and multiplying by exponential e imaginary x e negative I x t I stands for imaginary. So let's without wasting more time, let's go direct to solving our question. And because the conditions or the boundaries are true, you can see we are integrating from being t being less than 0 and t being greater than 0. So, having that in mind, we are going to our solution. Our solution will be, we are going to integrate from our formula. This is our formula. So it will not change. So you are going to have 4 pi, the root of the same. Looking here, this t is less than 0, and the formula is from negative infinity to infinity. So we are going to start with negative infinity to 0. Being looking for the function of ft. Our f function is e raised to c. So we are going to write e raised to t, then multiplying by e raised to this negative I x t. So that is e raised to I x t. That is the factor. Mind you, we have two conditions. We have how many conditions? We have two conditions. We have this one being less than 0 and this one t being greater than 0. So we are, what sign are we going to use to differentiate the two? Charles, we are going to use calculation. That is plus. Remember, we are still also going to integrate from 0 to infinity. And our function ft will be what? E raised from negative t raised to by negative t. So thank you. E negative t multiplied by these exponential. That is e I x t. When you reach this point, you have solved 40% of your question. Okay? Okay? Yes, you have solved 40% of your question. So, coming to integration here, you must be very careful. We have this part and you have this part. So, you're going to deal with each separately. You're going to deal with this one separate and this one separate. Then join them together using the sign. Yes, this sign of plus. Okay? Yeah, thank you. Thanks for trying. So, first thing you see here, we have a common base. And from our last lesson, I told you about the indices. We talked about indices, functions or equations or whatever, being with the same base. Base. So, we have same base. Okay, we dealt in logarithm. That is logarithm. And having this in mind, we are going to have e, t, because we are going to add. When the base is same, you add the power. When the base is same, you add the power. So we are going to add the power. That is minus I x t. Okay? That is the first one. Remember, we are still integrating from negative infinity to 0. Then the next one, you are going to integrate from 0 to infinity. Okay? Do the same. Have a common base. Okay? That is negative t minus I x t. Okay? Now you have the 2. Okay? Now you can continue by when you look here very keenly, we have TT, TT. So you can factor out T. We can factor out T. And in that manner, you need to, although my work looks not systematic, but I will try to make it more systematic. We're going to integrate from 0 and factoring out T, we are going to have 1 minus Ix factoring out T, okay? And then our sign remains integrating from 0 to infinity. Factoring out T, you are going to have negative 1 plus Ix, you factor out T, okay? Are you together?
Yes.
So that point, are you together?
Yes.
Now at this point, your integration is more simpler. Your integration is more simpler. Now you have half killed the giant. Now you have killed half the giant. 1, 2, 3, 4. Remember, in our first equation, remember we factored out 1 over root 2 I. Don't forget it. Very important. Don't forget. So in our equation, it looks like this. Integrating after we have simplified the equation. Don't forget 1 over root 5. So after taking in, integrating from negative infinity to 0, E1 help me 1 over x factoring out plus exponential negative 1 plus Ix t, having this, remember, this 1 over root pi, 1 over 2 pi is affecting the whole function, okay? Integrating, thank you. Integration from 0 to infinity, okay? Remember, it is this root 2 pi is affecting the whole function. So after this after dealing with this, we need also to continue. Don't leave this part, but because we want to break down our solution, let's assume, okay? Let's assume it, but it is still there. It is still existing, and it is still meaningful to our equation. When in our last class, I remember teaching you how to integrate exponential. Okay? Anybody having a problem integrating in exponential? I remember James, you had a problem. Did you so? Yes. Thank you. Now you are perfect. You are good at it. Okay? So you remember how to integrate an exponential. Thank you. Charles, how do we integrate this exponential? How do we integrate this exponential? As I taught you in our last class, I remember you had a problem. How do you integrate this?
Differentiate the power, then divide by the power.
Okay, he's saying you differentiate the power, then you divide by. Okay. So, thank you. So you are going to differentiate the power, then you divide by it, okay? So differentiating this one, we are going to have something like this. That is 1 minus Ix and t dividing by the 1 minus Ix. Okay? Are you together? Yes. Anybody having a problem? No. So initially, finally we have dealt with our exponential as far as integration is concerned. But remember the limit. What are the limits? What are the limits? Negative infinity to 0. Okay? Now you have dealt with this part of exponential. Okay? Remember now we have another part of exponential. Do the same to this side. So you're going to have plus e negative 1 plus Ix t dividing by negative 1 plus Ix. Okay? Remember the limit? The limit starts from from 0 to infinity. Okay? But I told you previously, don't forget this 1 over root 2 pi, but 2 pi because it is affecting and it is going to affect our solution. Are we together? Now when you have reached this point, now you can rest. You can rest, okay? If you had like 2 sleepless nights, you can rest now. You can sleep, okay? You are safe. Now you are safe. Because the only thing that you need to do here, remember this is not 8, it is infinity. Okay? Remember now that the remaining thing that is remaining is what you are taught in class 1. How to do 0 plus 0, 1 plus 1. Do you remember?
Yes.
Yes, that is what you need to do. But remember our function is a function of f t. Okay? Are we together? Our function is a function of f. So we are going to replace where there is 0. Where there is 0 where there is t we put 0. Where there is t we put infinity. Where there is t we put 0. Where there is t we put infinity. Okay? So that is how we are going to do right away. Right away. So, Charles, yes, now we are at a good, we are at a good place. Now this, what, when you reach here, in integration, A should minus B, okay? And A should be greater than B, okay? When it comes to integration, when you're integrating and you have reached to this point now when you are integrating, make sure that the bigger value minus the smaller value, okay? Not the other way around. The bigger value minus the smaller value. So in this case, between 0 and negative infinity, come out. Which is bigger? Between 0 and negative. Which is bigger? It is 0. So in this format, so we are going to start with 0, replacing to our function. Okay? Are we together, come out?
Yes.
And where is Hilda? Where is Hilda? At home. Oh. I will put that. Oh, now. I think when you go make sure she understands this because in our next exam, this one will be there. I promise you it will be there. Okay? Make sure she gets it well. I know she's a good student of mine. So replace where there is 0 and negative infinity correspondingly to this statement here. So you have come out. You have said which is bigger between 0 and negative infinity?
0.
0. So remember now it should be in this form. Okay? Bigger minus smaller. So come out being saying that t we are going to replace with 0. So it will be t 1 minus ix replacing it with 0. Okay? And remember at the denominator we don't have a value, we don't have t. We don't have t. So it is going to be 1 minus ix. Are we together? Minus. I've told you it is a minus b. The same area. Okay? Are we together? Yes. Yes. So the smaller one is negative infinity. Do the same. E 1 minus ix negative infinity all over 1 minus ix. Are we together up to there? Are we together? Yes. When you multiply anything, any number with a 0, it becomes 0. Okay? Okay? Any number by 0, it becomes 0. Are we together? Why you say, tell me 1 times 0 is 1? How is this derogatory? How is this 1 times 1? 0. Yeah? What?
Any number is 1.
Thank you very much. Kamau, you seem to be very fast. We are here. 0 times this black.
Oh, it's 0.
Is it 1? It is 1. It is 1. Is it 1? Yeah? So this one will be 8, this is 0. Any number, this number is like in this form, infinity. Any number is infinity is 0. So it will be 0 all over 1 minus ix. This one is 1 minus ix. So that is our first solution. 0 divided by a number is 0. Okay? And divided by 0 is 0. So any number is to 0 is 1. Okay? So our final solution is 1 minus ix. Okay? 0 remains 0. Okay?
Okay.
Yeah. So that is the first part. Your best with the first part. Remember, we have this part. Okay? Yes. So you're going to let me have it there. So you're going to replace. It is between the range is between 0 to infinity. 0 to infinity. Between infinity and 0, infinity is bigger than 0. Okay? Because it's a bigger number than 0. So you're going to replace where there is c, we put infinity. So this one is in this form, e negative 1 plus ix, our t being infinity, all over negative 1 plus ix. Okay? Now that is the first part. My board is a little bit smaller. When you put this one, you have said hapo tumesema nyuma ni tumesema previously that when you raise a number by infinity it becomes 0. So this one and this one cancel because 0 divided by a number is 0. Are we together? Yes, and because 0 it has no effect to our final solution, we go to the next in our range between 0 and infinity. We go to the next value, that is 0, and our limit will be negative 1 plus ix. Okay, raising to 0 all over negative 1 plus ix. 0 times a number is 0. Are we together? So when you put that value here being a 0, there is no problem. You are mathematically right. So 0 raised for a number is 1. Are we together? It's 1. So it is 1. Any number raised to 0, it is 1. Always, even in heaven, they will be 1. Are you together? Yes. Now, I'm lashing time because having this one that way. So the final thing will be 1 all over negative 1 plus ix. Very good. It was in this form. Now we have this 1 all over this value after integration. That is 1 minus ix after integration plus minus. Plus times minus is minus. Okay? Minus 1 all over
And the left.
ix. Yes. This is after doing our integration and everything is done. We're almost finishing. Minus plus. Minus times minus is equal to plus. So it is 1 all over root 2 1 ix plus 1 all over 1 plus ix. Yes. Now we can see we still have imaginary. Still have imaginary. These are fractions. Okay? And we're dealing with fractions, we need to have something called this common LCM. And the LCM, because we don't have a common number, we multiply it. So it will be 1 minus ix 1 plus ix. That is our LCM. This is our LCM, okay? So this one divided by this one cancels. This one multiplies there. So 1. When you divide our LCM by this one, the value is plus this one to cancels remain with plus 1 minus I x. Are we together? Yes. This is the value, this is the denominator, this is the numerator, this is the denominator. We want to eliminate the imaginary from the denominator. So we open the bracket from the denominator, and that one will be 1 plus ix minus ix 1 plus ix. For those that I don't know how we do it, I don't want to go straight to the answer. The second solution is 1 plus x squared after you have done your opening your bracket. Then b, you have 1 plus ix plus 1 minus ix. This and this cancels, okay? 1 plus 1 is 2. 2 all over our value here, 1 plus x squared. Are you together? And remember, I told you don't forget this value. So you are going to multiply it by times 1 all over 2 pi root. So the final answer, in your final answer, you should have this 2 all over root 2 negative 1 plus x squared. And that is the final answer. Make sure you go through the same and get that answer. Have a nice day.